So what is Lenz's law? So Lenz's law is named after the physicist Emil Lenz and was formulated in 1834. Lenz's law is based on Faraday's laws of electromagnetic induction, which states that a changing magnetic flux will induce a current in a conductor. However, Lenz's law tells us the direction of the induced current. So now let's do an experiment where we have a single coil and a bar magnet with its magnetic field lines emerging from the North Pole and coming down to the South Pole. Initially, there's no magnetic field in the coil. The magnetic flux through the surface will only change when moving the magnetic North Pole of the bar magnet toward the coil. Now, as the number of magnetic field lines passing through the cross-section of the coil changes, resulting in a change in the magnetic flux, the charge carriers in the wire materials are accelerated, thus forming an electric current. This phenomenon is called electromagnetic induction. But the question is, in which direction does this current flow? According to Lenz, the current will flow in such a way so that it could oppose the cause which is inducing current in the coil. So here, when we move the magnetic North Pole toward the coil, it induces a change in magnetic flux. As a result, a current will flow in such a way that it could create a magnetic field that is capable of opposing the change in magnetic flux induced by the motion of the bar magnet. We know that if electric current appears to be flowing counterclockwise, it acts as a North Pole, while an electric current appearing to be flowing in a clockwise direction will appear as a South Pole. We also know that similar poles repel each other, while opposing poles will attract each other. Thus, according to Lenz's law, to oppose the change in magnetic flux, the current in the coil must start flowing counterclockwise and start acting like a North Pole to repel an approaching North Pole. It is important to notice that the current will flow counterclockwise only as the North Pole approaches the coil. The current will stop when the bar magnet will stop, as there is no more change in magnetic flux. In short, the only thing the coil wants is to restrict the magnetic flux. Now let's move to the second case, in which we move the North Pole away from the coil. When the magnetic North Pole is moving away from the coil, then to oppose the change in magnetic flux, an electric current starts flowing in the coil such that it could attract the magnetic North Pole and oppose the motion of the magnet. Therefore, according to Lenz's law, the electric current will flow in a clockwise direction, create opposite pole, which is in this case South Pole. The South Pole will attract the magnetic bar moving away from the coil, thus opposing the change in magnetic flux.